What are the checks after placement? Checks after. There you do check the legality. Either you can do it through check legality in ICC or check place in Innovus. Check legality. Then check for congestion. Report congestion, and then you can even you can see the overflow numbers in log file. You can also report congestion. You can also check in the GUI where and why congestion is occurring. Then check for timing. How do you check timing? You can dump out reports using report timing, or in Innovus you can use time design to report a complete what do you do? Yeah, group by group analysis from reg to reg, reg to mem, whatever it is there. For all the path groups, if you want a comprehensive report, you can do time design. So these are the checks after placement. Check legality, and then check for congestion using report congestion and GUI, and check for your timing. Why will you not check hold? Because no skew. Hold is not checked because no skew. I will write it separately here. Next, we have what are clock exceptions. Clock exceptions are something we give in our clock spec file, asking the tool either to go trace through or not trace through, stop it, right? So some of these things are, like someone said exclude pin, float pin, stop pin, non-stop pin, right? So we will look at each of these. Let us say exclude pin. So first let us look at what's happening in clock tree. When I build a clock tree, tool will buffer my clock path. What are the factors the tool will consider while buffering my clock path? One is skew. Next is latency. It is not only these, it will also look for transition and cap. Let us say I have a long net, but skew is balanced. The tool won't leave it like that. It will add a buffer. It will not allow tran violation also. Okay. So these are things tool will look for, or let me put it as TRVs. Skew, latency, design rule violations. These are the things the tool will check for while adding a buffer in the clock path. And it will try to balance the skew between the sync pins. Right? Now, for some reason, for some reason, let us say my RTL guy said the path from flop 1 to flop 2 is not required. This we need not time. Okay, or flop 2 is not considered a timing path to any other flop in the design. So what we will do, we will say exclude pin as FF2 clock pin. It means that the tool will build the clock tree, but it won't balance the skew from FF2 to any other flop in the design. Why are we doing that? Because to balance the skew, tool will be adding so many buffers. Extra buffers will consume area, power consumption and all. Since my RTL guy himself said I don't need balancing for FF2, I will put that FF2 in exclude pin, which means you only check DRVs, only check DRVs and not balance skew. That is my exclude pin. You would have seen this in your clock spec file. This is not something new. You can go back and check once again. Then we have stop pin. Stop pin is balance only till that point. And not further. Right? So if I want to, this is FF2, there is output Q and there is combi and all, right? Should I balance this combi also with respect to FF1 or wherever the clock is going? No. So the with stop pin, what we mean is stop the balancing with FF2. Don't trace through FF2. Okay, do not trace through FF2. Stop at FF2. Right? So you might have already understood all our flops by default come under stop pins. All our sequentials will be default stop pins, right? Because every flop in our design, I will stop the balancing at this point, right? Skew balancing will stop at the flops. It won't propagate through the flops, right? Opposite of stop pin is non-stop pin. As the name itself says, do not stop balancing at the pin. Right? Please continue. Now, where will we find non-stop pins, right? Why do we not stop at the sequential, right? Sometimes what happens is this sequential is not actually a timing path. But this sequential is a part of a bigger circuit, which is actually generating a clock. The output of this is generated clock, gen clock 1, I would say. Why will we need to generate a clock, right? Why will we need to generate a clock is, let us say I have the time period of this clock is 1 nanoseconds. right? The time period of this clock is 1 nanosecond. I have to, generate a clock. I need a clock with 2 nanoseconds. For some reason in the design, only small portion of the circuit, I need a clock of 2 nanoseconds. So I have to divide it by 2 and then feed the clock to that specific module. So this will be main clock and this will be generated clock. How many of you seen generated clocks in your SDCs? Have you seen generated clocks in your SDCs? Yes or no, guys? Everyone must have seen generated clocks. What is happening? People are sleeping or?
Yeah, sir, we
Yes,
have seen it.
generated clocks, micro clocks.
Generated clocks are there in your design. Good. So these generated clock modules, right? There will be some modules generating this clock, right? They will take this main clock as input, give out the generated clock as output. This will contain some flip-flops. Those we will not use in report timing, right? For these, we will not fix setup and hold. So for those flip-flops, we have to just allow the clock to pass through. Therefore, we will say these are non-stop pins, right? So we have exclude pin, stop pin, non-stop pin. Then we have something called as float pin. Float pin is like, so I have a macro in my design, okay, and I have a flop. I have a macro and I have a flop. Usually macro setup times will be much higher. Macro setup times will be much higher. Let us say I am building a clock. I have built it 1 nanosecond and 1 nanosecond, right? There is a path from this register to macro. So it is a register to FF1 to macro path. I have built both 1 nanosecond, 1 nanosecond, right? The skew is, the latency is same. Latency is, okay, latency and time period also let us take it as same for simplicity. Then I will have 1 nanosecond for this output to reach my macro. But what happens is my macro setup times and will be much higher, and macro internal delays will also be much higher. Just like flop has clock to queue, macro will also have clock to queue, which is used in macro to register paths. So macro setup time will be higher, clock to queue will also be higher. So you cannot compare a macro to flop. So what we will do is, we will say either this macro already has a delay of 200 ps. This macro, we will say this macro is already having a delay of 200 ps. Now then, what will the CTS engine do? So since it is having 200 ps internally, now this it will optimize for 800 ps. This is just we are bluffing the tool. Okay, if we say macro clock pin as float pin, macro clock pin as float pin, and mention it already has 200 ps of internal delay, we are just bluffing the CTS engine, saying that my macro is already having an internal insertion delay of 200 ps. So the tool, instead of building the latency or building the clock for 1 ns, it will build for 800 ps. Now if it builds for 800 ps, I will have a good positive skew of 200 ps, right? So my macro clock will be like this. And ff2 clock, I will get good 200 ps if I'm trying to fix setup. This is called as macro modeling. Right? This is called as macro modeling. Now, why are we doing this macro modeling? Why are we doing this macro modeling, right? Because we are telling the tool, keep the skew as minimal as possible. Try to get a very good skew number, right? We are only telling the tool, reduce the skew as much as possible and come up with a good skew number, right? Now, how can we tell the tool that only for this path I need skew, right? While building CTS, we will set our target skew and target latency to build our clock tree. But how do I tell the tool only for this path I need positive skew so that I can fix my setup from macro to FF2? I cannot do that, right? I only have one option, skew target and latency target. So that is why we use this another option called macro modeling, wherein we tell the tool, we bluff the tool saying that tool, already there is 200 ps inside of the macro, so only build for 800 ps and not 1 ns. So now what will happen? This latency will be 800. This latency will be 1 ns. And I have a good 200 ps positive skew, to fix my setup. This is called as macro modeling. Any doubts in clock exceptions?
Do we also consider false paths and multi-cycle paths as exceptions?
Those are path exceptions. Those are timing exceptions, false path and multi-cycle path. These are clock exceptions. There is a difference between them.
Okay, okay.
Yeah.